Imagine waking up one morning and discovering that everything you were promised about the future was a lie. The shining cities on Mars, the gleaming rockets crossing space, humanity transformed into a multi-planetary species. It all sounds inevitable, almost natural. But the truth is different. No matter how hard we try, we will never reach Mars to live there. Not because we lack ambition, not because we don't have brilliant engineers, but because the universe imposes limits that cannot be negotiated. Mars is not humanity's next step. It is a carefully constructed mirage. This is Impossible Horizon, and tonight we are going to dismantle it.
It is not a lack of will that prevents us from reaching Mars, nor is it a matter of time. It is something far more uncomfortable. The physics of the universe do not allow it. For years, we have been told about the red planet as if it were a pending destination, as if we only needed better rockets, more money, or a little more patience. But this is not a video about dreams. It is a video about limits. Tonight, we are going to explore the real scientific reasons that make Mars a virtually unreachable destination for human life, not out of pessimism, but out of honesty. We are not here to romanticize space. We are going to look at it as it truly is, hostile, indifferent, and deeply incompatible with us. This channel exists for that very reason, to be a nightly refuge for slow thinking, a place to question easy promises and to understand the laws that govern the cosmos, even if we don't like them. Because only when we stop deceiving ourselves can we begin to understand our true place in the universe. To understand why Mars is not a new home, we have to stop thinking of it as a planet and start seeing it as a physical trap. During this journey, we're going to cross 5 barriers that cannot be bypassed with optimism or marketing. First, the lethal radiation of deep space, an invisible threat that pierces through bodies and spacecraft without permission. Second, the landing paradox, the technical problem of trying to land enormous human masses on a planet that does not want to receive them. Third, the mirage of water and the energy crisis, because surviving isn't just about arriving, it's about staying alive day after day in a world that does not cooperate. Next, we will see how the human body begins to fail, betrayed by insufficient gravity and an extreme cold that does not forgive mistakes. And finally, we will talk about the ethical and economic cost, the real price our civilization would have to pay for insisting on a fantasy. 5 barriers, not opinions, not conjectures. 5 reasons why Mars is not the future, but a warning. Radioactive hell. Space looks empty, but that is one of its most dangerous lies. In reality, it is filled with invisible death. On Earth, we live protected by 2 fundamental shields, the atmosphere and the magnetic field. Together, they deflect and absorb most of the radiation arriving from the cosmos. Without them, complex life on the surface wouldn't have lasted even a few thousand years. When you leave that protection, the universe begins to pierce through you. Deep space is saturated with solar particles and galactic cosmic rays, naked atomic nuclei accelerated by stellar explosions, traveling at nearly the speed of light. They are not weak. They are not stopped by aluminum. They pierce the hull of a spacecraft, and they pierce the human body as if it were air. A typical trip to Mars takes about 7 months one way. During that time, an astronaut receives a radiation dose equivalent to about 16,000 chest X-rays. That is not an exaggeration, it is a measurement. And the problem isn't just cancer, although that risk is enormous. The problem is that space radiation directly damages the brain. Astronauts have described flashes of light with their eyes closed, the moment a particle pierces the retina or the optic nerve. Neuronal inflammation, loss of mental clarity, deterioration of the immune system. The body begins to fail, and there is nothing you can do about it. Here, a logical question arises. Why not shield the spacecraft better? Because shielding has mass, and mass is the enemy of rockets. To effectively stop this radiation, you would need walls so thick that the spacecraft would become impossible to launch from Earth. Every extra inch of protection means additional tons of weight and additional tons of fuel. Physics closes the door once again. On Earth, radiation is a controlled risk. In space, it is a statistical certainty. It isn't a question of if it will happen, it's a question of when and how much damage will accumulate before you return. Mars isn't waiting for colonists. It is waiting for bodies exposed to an environment for which they were never designed. And this is only the first real price of trying to live outside of Earth.
7 minutes of terror. Reaching Mars is not the end of the problem. In many ways, it is the beginning of the worst part. The most dangerous phase of any Martian mission lasts barely 7 minutes. 7 minutes in which everything must function perfectly, or the mission ends up as a crater. Mars has the wrong kind of atmosphere. It is too thin to slow down a large spacecraft with parachutes, yet thick enough to cause aerodynamic chaos if you try to descend using only engines. It is the worst-case scenario. In current robotic missions, the vehicles weigh only a few tons. Even so, nearly half of all landing attempts throughout history have failed. Now, imagine a manned mission. We aren't talking about 2 or 3 tons. We are talking about 20 to 40 tons. The spacecraft, the remaining fuel, life support systems, heat shields, the humans. None of that can be slowed down with current technology without taking extreme risks. This is where the fuel problem appears. To land softly, you need powerful engines, but those engines need fuel, and that fuel adds mass, and that mass requires even more fuel to be slowed down. It is an exponential spiral. Every solution worsens the problem it's trying to solve. And as if that weren't enough, Mars adds another silent enemy: its dust. Martian dust is fine, abrasive, and electrostatic. It seeps into seals, blocks mechanisms, blinds sensors, and wears down critical surfaces. In a robotic landing, it is already a serious problem. In a manned mission, it would be a constant risk from the very first second. That is why every descent to Mars is a gamble where there is no room for human error, mechanical failure, or unexpected conditions. 7 minutes. That is all that separates a historic mission from a tomb on another planet. And even assuming you survived that controlled fall, the hardest part would still remain: staying alive there.
Critical survival, water, and energy. Once on Mars, the problem is no longer about arriving. The problem becomes surviving every single day. And it all starts with something so basic that on Earth we take it for granted: water. On Mars, liquid water cannot exist on the surface. The atmospheric pressure is so low that any drop would evaporate or freeze almost instantly. The water is there, but not as an accessible resource. It is frozen, buried beneath the soil, mixed with toxic salts called perchlorates, substances that damage the human thyroid, the nervous system, and the brain. This means that obtaining water on Mars isn't about drinking, it's about industrial mining. You have to excavate, break ice, heat it, purify it, separate toxins, store it in pressurized systems. All of that requires heavy machinery, constant energy, spare parts, and highly specialized technicians. Now comes the second problem: energy. Mars receives only 43% of the sunlight that reaches Earth. Solar panels produce less, and they fail just when they are needed most. Martian dust storms can last for weeks or months, blotting out the sky and reducing light almost to zero. For a small base to survive just one of those storms, it would take thousands of square meters of panels and hundreds of tons of batteries just to keep from freezing to death. Every system depends on another. Water needs energy. Energy needs maintenance. Maintenance needs spare parts. Spare parts come from Earth. There is no real redundancy. There is no margin for error. On Mars, a technical failure isn't a breakdown, it's a countdown. Life there wouldn't be a conquest. It would be a fragile balance sustained by machines that can never stop, and no artificial system works forever. The betrayed body and the cold. Even if we solved the radiation problem, even if we landed without a hitch, even if water and energy were guaranteed, there would still be one problem that cannot be fixed with engineering: the human body. Our biology is designed for one thing only: living on Earth. Mars has barely 38% of Earth's gravity. That might seem like enough to walk around, but it isn't enough to keep the human body intact. In low gravity, bones stop receiving mechanical stimulus. The organism responds by flushing out calcium. The loss of bone density reaches between 1 and 2% every single month. Muscles atrophy. Balance is disrupted. The heart, accustomed to pumping blood against gravity, becomes more rounded, less efficient. The vestibular system enters a permanent state of confusion. The body never truly adapts. It lives in a constant anomaly. And then there is the cold. The average temperature on Mars is around -60 degrees Celsius. In certain regions, it can drop to -125. At those temperatures, materials fail. Steel becomes brittle. Seals lose their elasticity. Joints crack. Maintaining a habitable temperature requires an enormous amount of energy. Just to compensate for the cold, a base would need hundreds of additional kilowatts continuously. A thermal failure isn't uncomfortable, it is lethal. On Earth, the body cooperates with the environment. On Mars, it fights against it without rest. There is no biological relief, no complete adaptation, only accumulated wear and tear. Living there wouldn't be an extension of human life. It would be a reduced, fragile, and dependent version of it in an environment that never stops attacking you. The corporate illusion and the trillion-dollar cost. At this point, it is inevitable to wonder, if Mars is so hostile, if the risks are so clear, why do we keep hearing that colonization is just around the corner? The answer isn't scientific, it's narrative. For years, figures like Elon Musk have repeated the same story, that humans will soon be living on Mars, that the first manned flights would arrive by specific dates, that costs would plummet, and that traveling there would one day be almost routine. But those dates have passed, one after another, unfulfilled. Starship, the system that is supposed to make that future possible, hasn't even demonstrated a stable orbital capacity yet without ending up destroyed in basic tests, and still it is presented as the ultimate solution. This is where the real problem appears. The numbers don't add up. Sending a manned mission to Mars with 6 people, with everything necessary to arrive, land, survive, and perhaps return, would have an estimated cost close to $1 trillion. That is not an exaggeration. It is the sum of energy, infrastructure, development, risks, and redundancies required. The famous figure of $100,000 per person has no relation whatsoever to real physics or space economics.
It is marketing. Space doesn't get cheaper just because we want it to. It doesn't respond to economies of scale like electronics or software. Every kilogram still costs energy. Every mistake is still catastrophic. Companies can promise futures, but they cannot change the laws of the universe. And when a narrative systematically ignores physical reality, we aren't looking at optimism. We're looking at a carefully designed illusion meant to keep a story alive, a story that is simply too attractive to let die.
There's an idea that we often mistake for defeat: accepting limits. We live in a culture that glorifies constant self-improvement, the idea that every frontier exists only to be crossed. But the history of humanity proves something different. We don't fly like birds. We accepted that limit, and then we invented airplanes. We don't breathe underwater. We accepted that limit, and we created submarines. Intelligence is not about denying limitations, it's about understanding them. And when we apply that perspective to space, something becomes evident. Human beings are not the ideal explorers of the cosmos. Our bodies are fragile. We depend on air, water, pressure, temperature, and a very specific gravity. Robots, on the other hand, do not have those problems. They don't suffer from radiation. They don't need oxygen. They don't eat. They don't get tired. They don't develop cancer. Exploring Mars with robots is not a surrender. It is the rational choice. In fact, for every human mission, we could send hundreds of robotic missions, safer, more durable, and thousands of times cheaper. And there is one comparison that puts everything into perspective. An Earth devastated by nuclear war, with damaged ecosystems and destroyed cities, would still be infinitely more habitable than Mars on its best day. Because even broken, Earth still has breathable air, adequate gravity, and magnetic protection. Mars is not a backup planet. It never has been. Accepting this doesn't trap us, it focuses us. It tells us where it makes sense to invest energy, resources, and talent, not in running away, but in caring. When we stop looking at Martian skies through a lens of fantasy, something curious happens. We begin to see the ground we walk on with greater clarity. Earth is not a provisional planet. It is not a waypoint before something better. It is a cosmic rarity, an extraordinary balance that we do not know how to reproduce anywhere else. For a long time, we were told that the future was out there, that we had to escape, that there would always be another world waiting. But science shows us something very different. The true challenge for our species is not to conquer Mars, but to learn how to live here without destroying what keeps us alive. Investing in clean energy, in health, in restoring ecosystems, in understanding our own planet better. That is not giving up on the future. It is choosing one that actually exists. Attempting to colonize Mars with our current technology and biology is like trying to cross the Pacific Ocean on a paper raft during a hurricane. It is not a question of bravery. It is simply that the laws of nature did not design that material to withstand that force. If this honest approach to space and science offers you something of value, if you appreciate looking at reality without unnecessary ornaments, subscribe and join us. We don't promise impossible futures here. We promise to think slowly, with rigor, and with respect for the only home we have. Good night.